This video is about understanding restrictions on acute and obtuse angles and applying properties of vertical angles and linear pairs to finding missing values. So an angle is formed by two rays with a common endpoint. The vertex is the common endpoint. So right here, this would be our vertex, and this could be our angle. When we are naming angles, we need to name angles either by one letter if it's the only angle at that vertex, a number, or three letters where the vertex is in the middle. So number one, we can name the angle A, we can name it angle 1, or we can name it angle ART or angle TAR. In number two, there are three angles. So we can't call this angle E, because if I say angle E, we're not sure are we talking about the top, the bottom, the whole angle. So instead, we have to use only the number or the three letters. So for the top angle, so this angle up here, we could call it angle 1. We could also call it angle BEA, or angle AEB. The bottom angle then, we can call that angle 2. We can call it angle REA or angle AER. And then our whole angle, we can't use a number because it's putting the two angles together, so we can only use three letters. So we could call it angle BER or angle REB. Now, with angles, there are four types of angles. There's an acute angle where the measure has to be between 0 and 90 degrees. There's the measure of a right angle, which is always equal to 90 degrees. There's an obtuse angle, which is between 90 degrees and 180 degrees. And then there's a straight angle, which always equals 180 degrees. So in number one, P is acute. So using this angle here, we know that P is acute. What are the restrictions on angle P? And then what are the restrictions on X? So the restrictions on P are what measurements can P be between? Well, if this is an acute angle, that means the angle has to be between 90 and 0. So we have 0 is less than the measure of angle P, which is less than 190, or which is less than 90. Then when we want the restrictions on X, we're going to take what this angle is, and we're going to put it in here and solve for X. So when we rewrite this equation, we have 0 is less than 3x minus 27, which is less than 90. So to solve a compound inequality, whatever we do in the middle to get the x by itself, we need to do to both sides. So first thing we're going to do is add 27. So we get 27 is less than 3x, which is less than 117. Then we can divide everything by 3. So we get 9 is less than x, which is less than 39. This means if we pick any x value between 9 and 39, that's going to give us an angle measurement equal to something between 0 and 90 degrees. Now, in 2, we're using the same angle, but we're switching so that P is obtuse. So an obtuse means it's a bigger angle, so that means that the measure of angle P is going to be between 90 and 180. When we substitute in to find the r, we have 90 is less, or the x, we have 90 is less than 3x minus 27, which is less than 180. Again, we're going to add 27 to both sides. So we get 117 is less than 3x, which is less than 207. When we divide by 3, 39 is less than x, which is less than 69. So x would fall between these two numbers to get us a measure of an obtuse angle if we were to sub an x value in. In number 3, given q and a y value, determine the classification. So what we're going to do here is we're going to take these y values and we're going to put it in for y to see what angle measurement we would get, and then we can classify our angles. So first we would have 5 times 7 plus 20. which gets us 35 plus 20, which is 55 degrees. An angle that is 55 degrees is acute. Next, we have 5 times 12 plus 20. So 5 times 12 plus 20. 5 times 12 is 60, plus 20 is 80 degrees, which is also an acute angle. And our last one, we have 5 times 24 plus 20, which gets us 120 plus 20, so 140 degrees. This time we have an obtuse angle. In number 4, what value would make P obtuse? Choose all that apply. So we're going to put X in for each of those. So 4 times 33 minus 80 gets us 52 degrees. 4 times 44 minus 80 gets us 96 degrees. 4 times 51 minus 80 is 124 degrees. And 4 times 65 minus 80 is 180. So remember, an obtuse angle is going to be between 90 and 180 degrees. So that would be B and C. Some more vocab with angles then. We have adjacent angles, which are angles that have the same plane with a common vertex and a common side, but no common interior. So they're next to each other. So if we have an angle like this, and like this, angle 1 is adjacent to angle 2. A linear pair then is a special type of adjacent angle because it's going to add to be 180 degrees. So a linear pair, we're going to have two angles that are next to each other, but we now know that the measure of angle 1 plus the measure of angle 2 is 180 degrees. And then we have vertical angles. Vertical angles are formed by crossing lines. So we have 4 angles here, and our angles that are across from us are congruent. So we have angle 1, 2, 3, and 4. We would have angle 1 is congruent to angle 2, or sorry, angle 3, because they're across from each other. Angle 2 is across from angle 4, so they are congruent. They would have the same measure. Also with vertical angles then, while the vertical angles are congruent, the angles next to each other are going to be linear pairs, so they are going to be supplementary. So in number 5, we want to find the missing angles. So 120 degrees is across from angle 2, so that's also 120 degrees. Then we know that 120 degrees and angle 1 form a straight line. So we can subtract 180 minus 120 will get us 60 degrees, which means angle 3 is also 60 degrees because they are vertical angles. In number 6, we see that we have 35 degrees, which is across from angle 2. So angle 2 is also 35 degrees. We see 73 is across from angle 4, so those are also vertical angles. When we use our straight line to get angle 1, we can do 180 minus 35 minus 73. And we get 72 degrees. So angle 1 and angle 2 are 72 degrees. In number 7 and 8, we want to solve for x and then find the measure of angle 1. So we know that our opposite angles are congruent, so we can set them equal. 5x plus 28 equals 8x plus 4. We can subtract 5x from both sides, so 28 equals 3x plus 4. We can subtract 4 from both sides, so 24 equals 3x. We can divide by 3, so x is 8. Once we know x is 8, we can substitute into either angle. So I'm going to do 5 times 8 plus 28, and I get 68 degrees. So then to find angle 1, I can use my straight line, and I can subtract from 180. So 180 minus 68 will get us 112 degrees. In number 8, when we set our angles equal to each other, 13x minus 20 equals 2x plus 57. We can subtract 2x from both sides, so 11x minus 20 equals 57. We can add 20 to both sides, so 11x equals 77. And we divide, x is 7. So then we can substitute 13 times 7 minus 20 is 71 degrees. I can use my straight line. So 180 minus 71 gets us 109 degrees. Number 9, using our vertical angles, we want to find M, N, and P. So we know that P and N are going to be the same measure at some time, but we don't know those measures yet. What we can do is use 141 and subtract from 180 to get P is 39 degrees, so N is also 39 degrees. Then to get angle M, we can use our straight line, and we know 2 of those 3 angles, so we can subtract 180 minus 39 minus 43. And we get 98 degrees. In number 10, use linear pair. So remember, linear pair means that the angles add up to 180 degrees. So we have angle BAE is 5x plus 19, and EAS is 10x minus 4. So together we know they form a straight line, which is 180 degrees. So our equation is 5x plus 19 plus 10x minus 4 equals 180. We combine like terms, 15x plus 15 equals 180. We can subtract 15 from both sides. So 15x equals 165. When we divide, x is 11.